Electric water cooler outlets need ground fault circuit interrupter (GFCI) protection. Outlets within 6 feet of electric water coolers also need ground fault circuit interrupter (GFCI) protection. The National Electrical Code (NEC) Section 210.8 covers ground fault circuit interrupter (GFCI) protection. NEC Section 210.8b covers ground fault circuit interrupter GFCI protection in other locations. NEC Section 210.8b3 specifically addresses water coolers. All 125 volts, single phase, 15 amps and 20 amps receptacles installed outdoors, in bathrooms, and in other wet or damp locations must be ground fault circuit interrupter GFCI protected. All receptacles located within 6 feet of a sink, countertop, or wet bar in the kitchen, bathroom, laundry area, and similar locations must be ground fault circuit interrupter GFCI protected. The electric water coolers are considered to be wet locations, so the outlet that powers them must be ground fault circuit interrupter GFCI protected. Since outlets within 6 feet of a wet location are also required to be ground fault circuit interrupter GFCI protected, any outlets within 6 feet of an electric water cooler must also be ground fault circuit interrupter GFCI protected. A ground fault circuit interrupter GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as 1/40 of a second. It works by comparing the amount of current going to and returning from equipment along the circuit conductors. Any difference in current indicates leakage. The ground fault circuit interrupter GFCI interrupts power supply if a ground fault is detected, which reduces the risk of electric shock. Ground fault circuit interrupters GFCIs are required in locations where electrical equipment may come into contact with water, reducing the risk of electric shock. NEC 210.8 specifies locations where ground fault circuit interrupter GFCI protection is required. This includes bathrooms, kitchens, garages, outdoors, and other locations where moisture is present. Electric water coolers are considered wet locations, as there is a high risk of water spillage or condensation, increasing the risk of electric shock. Outlets within 6 feet of a wet location are also required to be ground fault circuit interrupter GFCI protected. This is because water can splash or spill onto nearby surfaces, potentially creating an electrical hazard. The 6-foot rule extends ground fault circuit interrupter GFCI protection to areas where there is a reasonable likelihood of contact with water. There are different types of ground fault circuit interrupters GFCIs, including receptacle type, circuit breaker type, and portable ground fault circuit interrupters GFCIs. Receptacle type ground fault circuit interrupters GFCIs are installed in place of standard electrical outlets. Circuit breaker type ground fault circuit interrupters GFCIs are installed in the electrical panel and provide protection for the entire circuit. Portable ground fault circuit interrupters GFCIs are used for temporary protection in areas where permanent ground fault circuit interrupter GFCI protection is not available. When installing ground fault circuit interrupters GFCIs, it is important to follow the manufacturer's instructions and local electrical codes. Ground fault circuit interrupters GFCIs should be tested regularly to ensure they are functioning properly. To test a ground fault circuit interrupter GFCI, press the test button on the device. The ground fault circuit interrupter GFCI should trip, cutting off power to the outlet. If the ground fault circuit interrupter GFCI does not trip, it should be replaced. Ground fault circuit interrupters GFCIs are an essential safety device that can help prevent electric shock. By understanding the requirements for ground fault circuit interrupter GFCI protection and installing ground fault circuit interrupters GFCIs in appropriate locations, the risk of electrical injury can be significantly reduced. Always consult a qualified electrician for any electrical work to ensure safety and compliance with local codes. Regular inspection and testing of ground fault circuit interrupters, GFCIs, are important to maintain their effectiveness. Educate yourself and others about the importance of ground fault circuit interrupter, GFCI protection to create a safer environment. The NEC is a comprehensive set of standards and guidelines for electrical installations. It is updated every 3 years to reflect changes in technology and safety practices. Understanding the NEC is essential for anyone involved in electrical work, including electricians, contractors, and inspectors. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections, each addressing a specific aspect of electrical safety. Adhering to the NEC helps ensure that electrical installations are safe and reliable. Local jurisdictions may adopt the NEC with or without amendments, so it is important to check with local authorities to determine the applicable code requirement. Continuing education and training are essential for staying up to date with the NEC and best practices in electrical safety. The purpose of ground fault circuit interrupter, GFCI, protection is to detect ground faults and quickly interrupt the flow of electricity to prevent electric shock. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. Ground fault circuit interrupters, GFCIs, are designed to detect even small ground faults that could be lethal. Ground fault circuit interrupters, GFCIs, work by monitoring the current flowing in the circuit's hot and neutral wires. If there is a difference of more than a few milliamperes between the two, it indicates a ground fault. When a ground fault is detected, the ground fault circuit interrupter, GFCI, trips, cutting off power to the circuit in milliseconds. This rapid response time is crucial in preventing serious injury or death from electric shock. Ground fault circuit interrupters, GFCIs, are required in areas where there is a high risk of contact with water or moisture, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters, GFCIs, can be installed as receptacles or circuit breakers. Receptacle ground fault circuit interrupters, GFCIs, are installed in place of standard outlets and protect only the outlets on that circuit. Circuit breaker ground fault circuit interrupters, GFCIs, are installed in the electrical panel and protect the entire circuit. It is important to choose the appropriate type of ground fault circuit interrupter, GFCI, for the application and to install it correctly. Ground fault circuit interrupters, GFCIs, should be tested regularly to ensure they are functioning properly. The test button on the ground fault circuit interrupter, GFCI, simulates a ground fault and should cause the ground fault circuit interrupter, GFCI, to trip. If the ground fault circuit interrupter, GFCI, does not trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters, GFCIs, are an essential safety device that can help prevent electric shock. By understanding how ground fault circuit interrupters, GFCIs, work and installing them in appropriate locations, you can significantly reduce the risk of electrical injury. Always consult a qualified electrician for any electrical work to ensure safety and compliance with local codes. Water coolers are considered wet locations because they often have water lines and condensation can form on the exterior of the unit. This creates an environment where there is an increased risk of electric shock if there is a fault in the electrical system. The requirement for ground fault circuit interrupter, GFCI, protection for outlets serving water coolers is intended to protect people from this risk. The 6-foot rule for ground fault circuit interrupter, GFCI, protection around wet locations is based on the idea that water can splash or spill onto nearby surfaces. This means that even if an outlet is not directly exposed to water, it can still become a shock hazard if it is located within 6 feet of a wet location. The specific requirements for ground fault circuit interrupter, GFCI, protection can vary depending on the local electrical code. It is important to check with your local building department or a qualified electrician to ensure that you are complying with all applicable requirements. In addition to ground fault circuit interrupter, GFCI, protection, there are other safety measures that can be taken to reduce the risk of electric shock around water coolers. These include ensuring that the water cooler is properly grounded and that all electrical connections are tight and secure. It is also important to keep the area around the water cooler clean and dry to prevent water from accumulating. Regular maintenance of the water cooler can also help to prevent electrical problems. This includes checking the water lines for leaks and inspecting the electrical components for signs of damage. By following these safety guidelines, you can help to ensure that your water cooler is safe to use. The National Electrical Code, NEC, is a set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, NFPA, and is updated every 3 years. The NEC is widely adopted by state and local jurisdictions and is used to ensure that electrical installations are safe and reliable. The NEC contains detailed requirements for a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is organized into chapters, articles, and sections, each addressing a specific aspect of electrical safety. The NEC is a complex document, and it can be difficult to understand all of its requirements. It is important to consult with a qualified electrician or electrical engineer if you have any questions about the NEC. The NEC is not a law itself, but it is often adopted by state and local jurisdictions, making it a legal requirement to comply with its provisions. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. The NEC is constantly evolving to reflect changes in technology and safety practices. It is important to stay up to date with the latest version of the NEC to ensure that your electrical installations are safe and compliant. The NEC is an essential resource for anyone involved in electrical work. By understanding and following its requirements, you can help to ensure that electrical installations are safe and reliable. The NEC provides specific guidelines on the installation and use of ground fault circuit interrupters, GFCIs. These guidelines cover various aspects, including the locations where ground fault circuit interrupters, GFCIs, are required, the types of ground fault circuit interrupters, GFCIs, that are permitted, and the testing and maintenance requirements for ground fault circuit interrupters, GFCIs. The NEC also provides information on the proper wiring and grounding of electrical systems to ensure that ground fault circuit interrupters, GFCIs, function correctly. It is important to consult the NEC for detailed information on ground fault circuit interrupter, GFCI, requirements and to follow all applicable codes and standards when installing and using ground fault circuit interrupters, GFCIs. Ground fault circuit interrupter, GFCI, protection is a critical safety measure that helps to prevent electric shock injuries. By understanding the requirements for ground fault circuit interrupter, GFCI, protection and following the guidelines provided in the NEC, you can help to create a safer environment for yourself and others. Electrical safety is a serious matter, and it is important to take all necessary precautions to prevent electrical accidents. This includes using ground fault circuit interrupters, GFCIs, in areas where there is a risk of water exposure, such as around water coolers and other wet locations. Remember, when working with electricity, always follow the proper safety procedures. Turn off the breaker and use the right equipment. A water cooler presents a specific risk profile. Firstly, there is the risk of splashing or spillage of the water itself during refilling or use. Secondly, condensation can form on the cooler's surfaces, creating moisture. Thirdly, the cooler's internal components, such as the water reservoir and cooling system, could leak. These factors contribute to the classification of a water cooler location as damp or wet, necessitating ground fault circuit interrupter, GFCI, protection. The NEC doesn't simply state water coolers need ground fault circuit interrupter, GFCI, protection. It uses broader categories like wet locations and lists specific examples. By classifying the water cooler area as a wet location, the general requirements for such areas automatically apply, mandating ground fault circuit interrupter, GFCI, protection for receptacles serving the cooler. The 6-foot rule is an extension of this protection philosophy. It acknowledges that water can splash or spread beyond the immediate vicinity of the source. An outlet 5 feet away from a water cooler, although not directly splashed during normal use, could still be exposed to moisture from spills or condensation, potentially creating a shock hazard. Therefore, the NEC mandates ground fault circuit interrupter (GFCI) protection for any outlet within that 6-foot radius. This rule aims to encompass a wider area of potential risk, preventing shocks even in less obvious scenarios. Ground fault circuit interrupters (GFCIs) themselves come in different forms. A ground fault circuit interrupter (GFCI) receptacle replaces a standard outlet, providing protection only at that specific location. A ground fault circuit interrupter (GFCI) circuit breaker installed in the electrical panel protects the entire circuit it feeds, including all outlets and devices connected to that circuit. A choice between these depends on factors like the wiring configuration and the desire for broader protection. Regardless of the type, the basic function remains the same, constantly monitoring current flow and tripping in milliseconds if a ground fault is detected. The regular testing of ground fault circuit interrupters (GFCIs) is crucial. The test button simulates a ground fault, verifying that the device can quickly interrupt the circuit. Monthly testing is generally recommended, and a failure to trip upon pressing the test button indicates a faulty ground fault circuit interrupter (GFCI) that needs immediate replacement. Neglecting this testing can defeat the purpose of having ground fault circuit interrupters (GFCIs) in the first place, creating a false sense of security. The area within 6 feet of a water cooler should be considered part of the wet location risk zone. Any receptacles in the area must be ground fault circuit interrupter (GFCI) protected. Always consult the most recent edition of the NEC and any relevant local amendments. These codes are constantly updated to reflect evolving safety standards. Do not attempt electrical work without proper training and qualifications. Contact a licensed electrician for any installations, repairs, or inspections. Ground fault circuit interrupter (GFCI) protection is not a replacement for safe work practices. Treat all electrical circuits as live until proven otherwise, and always follow lockout/tagout procedures when working on electrical equipment. Understand the principles of grounding and bunding. A properly grounded electrical system provides a low impedance path for fault current, helping ground fault circuit interrupters (GFCIs) to operate effectively and minimizing shock hazards. Ensure that all electrical equipment is approved and listed by a recognized testing laboratory. Look for labels like UL or ETL, which indicate that the equipment has been tested and meets safety standards. Regularly inspect electrical cords and plugs for damage. Replace any damaged cords or plugs immediately, and avoid overloading outlets with too many devices. Educate occupants and employees about electrical safety. Explain the purpose of ground fault circuit interrupters (GFCIs), the importance of testing them, and how to recognize potential electrical hazards. Keep electrical panels and equipment accessible and clear of obstructions. This ensures that emergency responders can quickly access the equipment in case of a fire or other emergency. Properly label all electrical circuits and equipment. This helps to prevent confusion and ensures that the correct circuits are energized during maintenance or repairs. Use appropriate personal protective equipment (PPE) when working with electricity. This may include gloves, safety glasses, and insulated tools. Follow all applicable safety regulations and guidelines. This may include OSHA standards, NFPA codes, and local electrical codes. Never take shortcuts or bypass safety procedures. Electrical safety is not something to be taken lightly, and a moment of carelessness can have serious consequences. Remember, electrical safety is everyone's responsibility. By following these guidelines, you can help to create a safer environment for yourself and others. Understanding the specific requirements of NEC Section 210.8b3 is critical for ensuring compliance and safety around water coolers. Remember that the interpretation and enforcement of the NEC can vary depending on the local jurisdiction, so it's always best to consult with a qualified electrician or building inspector to clarify any specific requirements or address unique situations. This information is for general guidance only and should not be considered a substitute for professional advice from a licensed electrician or qualified electrical engineer. Always consult with a qualified professional for any electrical work or to ensure compliance with local codes and regulations. The information provided herein is based on general knowledge and understanding of electrical safety principles and the National Electrical Code (NEC). However, electrical codes and regulations can vary significantly depending on the jurisdiction, and interpretations may change over time. Therefore, it is essential to consult with qualified professionals and local authorities to ensure compliance with all applicable requirements. This discussion addresses the requirement for ground fault circuit interrupter (GFCI) protection for outlets serving electric water coolers and those within 6 feet, as mandated by the National Electrical Code (NEC). The NEC considers electric water coolers to be wet locations due to the potential for water spillage, condensation, and leaks. Consequently, all 125 volts single-phase, 15 amps and 20 amps receptacles serving these coolers must have ground fault circuit interrupter (GFCI) protection. Furthermore, the NEC extends this protection to all receptacles within 6 feet of the water cooler, recognizing the risk of water splashing or spreading to nearby outlets. This ensures a safer environment by minimizing the risk of electric shock. The NEC, updated every 3 years, is the definitive guide for electrical safety standards. While this discussion offers insights into its requirements, consulting the latest edition and local amendments is crucial for accurate implementation. Remember, adherence to these standards is not just about compliance, it's about protecting lives.